Everyone. This is class 18 and part 2. In this part, we're going to talk about equality and inequality constraint into an optimization problem. So this is the function again we're trying to optimize. There's two constraints. One is your equality constraint, another is inequality constraint, right? So what is inequality constraint? Where it comes from? Let's say you have a power plant that has upper limit and lower limit. It cannot exceed the upper limit, also cannot exceed the lower limit because the economic reason, right? So we have a power plant, let's say PI, any power plant, real power cannot exceed, let's say 1,000 megawatt, also cannot go below 100 megawatt. So this is the inequality constraint right here, right? So that is what happens in a real term, right? So let's see how you put them together. So again, we do the same thing, Lagrange multiplier. So this part is for the equality constraint, this part is for the inequality constraint. And multiplier for inequality constraint is mu j, and multiplier for the equality constraint is lambda I, and this is the function you're trying to optimize. So we have new function to optimize now, and what you do is the same thing. You take the first derivative of all of them, partial derivative, and here's the condition here. This is the inequality constraint here. That means that mu j uj equal to 0, and your mu j can be greater than 0. So that what that means is that the uj equal to 0 when mu j is still greater than 0. This is called one of the I'm not going to go into that. It's one of the necessary condition for Kuhn-Tucker necessary condition. Okay. What is basically saying over here is that when you hit one of the limit, if you hit the limit, let's say your optimization problem solving first 2-3 round, or first round you hit the power plant I just showed you, you have a for one power plant limit was 1,100, you hit the 1,000 limit. So what you do, you set upper limit now, so PI would not change anymore. It would be out of the optimization problem now. You just set it to what? 1,000 megawatts. That's what it's saying actually. In a plain side, that's what it's saying for the necessary condition. All right. So let's put it together here. So I have this same function to try to optimize. This was my equality constraint, which was my circle. Now I have inequality constraint here, which is my straight line. All right. So I do the same thing over here. I put it together. So this is the inequality constraint part here. This is the equality constraint part over here. This is the function, and I have the new Lagrange function over here. Then I took all those partial derivative of x, y, lambda, and mu. Then I solve them. If you solve them, you'll see that you have a set of solution x, y, 5, 2. Lambda value this one, mu value this one here, and another set of solution with the new lambda value and mu value. So which one is the minimum? How do you know that which one is minimum? That's where it comes to your Hessian matrix. So let's go back and build the Hessian matrix over here. And if you look at here, Hessian matrix only involve the xy function, and that will be the same Hessian matrix we did before because the same function. So your Hessian matrix would be here. So now if I test it for two different lambda value here, first one I can test it, let's say x for this side over here. If I test it with this side over here, my h becomes 1.6, right? It's negative 2.5, so 1.6, right? It's negative 0.2, so it becomes 0.4, so it's 1.6, 0, 0, 1.6. And if you remember from the last one, its eigenvalue would be 1.6, and 1.6 a positive definitive matrix, right? Then other one for this set of value over here, h would be so 3.6 to negative 1.6, 0, 0, negative 1.6, right? So eigenvalue for this one would be negative 1.6, negative 1.6. This is not a positive definite matrix. That means the minimum point is this. right? And you can see this right here, that's the minimum distance, who is basically doing the meeting the both condition, right? That's why you find the solution for equality and equality constraint problem. All right, I will going to talk about the lesson 19 next video.